All right, this is Mr. Gillum, and today we're going to talk more about factors, but instead of greatest common factors, we're going to do something called factoring. It's a verb. Okay, it's going to be called factoring, and so we're going to need the greatest common factors, and we're going to be manipulating these expressions we've been working with. Now remember, an expression doesn't have an equal sign, and what we're doing is we're going to factor it. So all that work we did with GCF yesterday, huge for today. Okay, going to be very important. So let's take a look here. By the end, I want you to be able to factor linear expressions. All right, and I think you guys are going to catch on pretty quick. Oh, go to the next page. There we go. Okay. Factoring. When we factor in math, we're finding the actual factors of the expression. That is, we're looking what was distributed. Distributed is what we're going to put in that little blank right there. Let's find a color that'll show up. Distributed. Thus, we are undistributing. Undistributing. Okay, so what we're doing essentially is we're undistributing things. Okay, we're doing the opposite of distributing property. We're actually going to take out the greatest common factor. And so there's really nothing to it, boys and girls. I think you're going to like this. If I undistribute from this linear term, 6x plus 10, there is a number that we are thinking of that 6 and 10 share. So if I think of 6 and I think of 10, and I'm trying to find the greatest common factor between the two numbers. I have a 3 and a 2. I have a 5 and a 2. Okay, so I have, for 6, my prime factors are 2 and 3. And for 10, my prime factors are 2 and 5. Looks like they share a 2 in common. So my greatest common factor in this case is 2. So what I'm going to do is I'm going to undistribute the 2. I'm going to put them on the outside of the parentheses. But if I undistribute the 2, whatever is left inside here and on the 6's is going to go in front of the x term, 3. And whatever is left for the prime numbers in the 10 is going to go in where the 10 used to be, 5. So what we did was, instead of distributing, we're going backwards. We're undistributing. Now, these should be equal. Now we do have an equal sign, okay? 2 times 3x is 6x, and 2 times 5 is 10. 2 is a factor of 6x plus 10, and 3x plus 5 is a factor of 6x plus 10. So this is called factoring. We're undistributing. Okay, so it's important that we're good with our number trees. This is a really important part that we know how to do those. Okay, so now I'm looking at 4, in this case negative 4, and negative 10. So let's look at 4 and 10. Looks like my prime numbers for 4 are 2 and 2, and for 10, 2 and 5. So 4, I have a 2 times 2. 10, I have a 2 times 5. Now we practiced this yesterday, so we should be pretty good at factor trees. It looks like my common prime factors are 2. So that must mean it's the greatest common factor as well. Now, if you ever see this part with the x with the variable, if there's a variable term and a constant term, the variable term is negative. You want to take out the negative. You need to undistribute the negative as well. So since the greatest common factor is 2, I'm going to undistribute a negative sign and a 2. What's left is, since I already used the negative sign up, it's on the outside, what's left is a 2 and a 5. Okay, so to check to make sure I'm on the right track, is negative 2 times 2x negative 4x? And is negative 2 times 5 negative 10? Yes, it is. So I'm going to factor negative 4x minus 10 into negative 2 times 2x plus 5. Okay, it's going to take a little practice. It's called undistributing. We call it factoring. It's a verb. Okay, and so that's what we're practicing today. So let's take a look at some more. These are called linear expressions. There's 2 terms. One has a variable, one is a constant. And I'm going to look at the 2 numbers here, between 2 and 8. Now 2 is just a little seed factor tree. He's already a prime number, so I'm just going to circle him. 8 I know is 4 times 2, or 2 times 2. And so what I have here is I have 2, and I have 8, which is a 2 times 2 times 2. Now remember, your factor trees, your prime factor should multiply to get your original number. 2 times 2 is 4, times 2 is 8, so 8. So we're good here. Now they only share 1, 2. And so in this case, that must be the greatest common factor. So my greatest common factor is going to come outside the parentheses. And I need an x part and a constant part. There's nothing left with the 2, so we don't just put nothing, 0x, there has to be something there. And we don't write 1 as a prime, but we do take 2 times 1x to get 2x. So in this case, we just don't write anything here. We just assume we leave it as a 1. On the second part, I still have a 2 times 2 left over from my 8 that I haven't pulled out of the parentheses yet. 2 times 2 is 4. And in this case, actually, we want it to be a negative 8, so we want to put minus 4. So to make sure that I'm on the right track here, 2 times x is still 2x. 2 times negative 4 is still negative 8. So I have factored it by taking out the number that they have in common. All right. So let's take a look. I have 16. And I'm going to factor tree him. And we should be getting pretty good at the factor trees, knowing which ones are prime. And I have 22. All right. So my 16 is going to take 4 2's. And just to check, let's make sure 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're good there. And 22 has 2 times 11. And once again, they only share one prime factor. So in that case, that's just going to be our greatest common factor. So we're going to say 2 on the outside. I need an x term and I need a number. My x term in this case, I have 3 2's left over. And 2 times 2 times 2 is 8. So I'm going to put 8 in there. For my 22, I have an 11 left over, and I want it to be a positive, so I'm going to say plus 11. I need to make it positive because when I redistribute it, it needs to start out with what I wanted or what I had in the beginning. So I know 2 times 8x is 16x, and 2 times 11 is 22. This is called factoring. I've undistributed a 2. Okay? So practice makes perfect, boys and girls. Let's take a look at a few more. It says a rectangle has an area of 4x plus 6. It says the width is 2. What is the length? So in this case, what it's asking me to do is I took 2 times something to get 4x plus 6. Well, to get a 2 change it into a 4x, I would have to multiply by 2x. And to take 2 times something to get 6, I would have to do plus 3. So what is the length? It must be 2x plus 3. Because if the width is 2 and this was 2x plus 3 and I multiplied them for the area, that would give me 4x plus 6. Once again, this rectangle has an area of 9x minus 12. All right, it says that the width is 3x minus 4. What is the length? Well, 3x minus 4 times something that we don't know has to equal 9x minus 12. So I know that 3 times 3x would equal 9x, and 3 times negative 4 would equal negative 12. So this is the factored form of the area. All right. Take another look. We're just going to practice factoring. Okay, and these are important, so we're going to do quite a few examples here. Just plain old factoring, no word problems. So I'm looking at the 15 and the 10. That's where I'm going to start. 15 and 10. Let's do a little factor tree here. There's my primes. And there's my prime. So for 15, I'm going to write him first because he's the part with the x on it. And 10, like so. Okay. Now, they only share the 5 in common. So in this case, that's my greatest common factor. 5. I mean an x term and a constant. Well, I want to make sure that I end up with 15. So if I took the 5 out, all I have left is a 3. And for 10, I want to make sure I have positive 10 here. So what I have left is a 2, a positive 2. Let's double check our work here. 5 times 3x is 15x, and 5 times 2 is 10. Therefore, 5 times 3x plus 2 is the factored form of number 1. Let's take a look at number 2. I'm looking at just the numbers again, 7 and 3. And in this case, they just both happen to be prime numbers. So 7, the only factor is 7. 3, the only factor is 3. And unfortunately, they don't have anything in common. So there's nothing to factor here. Okay, so if it cannot be factored, write cannot be factored. So let's write cannot be factored. Okay, Let's take a look at 6x plus 9. I have a 6 and I have a 9 I want to look at, and we're going to do 3 times 2. There's my primes, and in this case 3 times 3. Those are my primes. So 6 has the primes of 3 times 2, and 9 has the primes of 3 times 3. They share a 3 together, and that's the only prime they share together. So in this case, the greatest common factor will be 3. If I want my variable term to have an x on it, of course, so if I take the 3 out, I am left with a 2. And if I take the 3 out of the 9, I'm left with a 3. And I want it to be positive, so I put plus 3, because I know positive times a positive is a positive. Here's my distributive property. 3 times 2x is 6x. 3 times 3 is 9. So this is the factored form of that linear expression. Ooh, some bigger numbers this time. So on number 4, we're looking at 30 and 25, and it's a negative 25, so we need to make sure we're careful on this one. 6 times 5, and there's a prime, and then 3 times 2. Those are both primes. 25, there's a 5 and a 5. So for 30, which is the one with my variable on it, I have a 2 times 3 times 5. And for my 25, I have a 5 times 5. We just share a 5 in common in this case. So that's going to be my greatest common factor, 5. I need a linear term, and I need a constant. When I take the 5 out of the 30, what I'm left is a 2 times a 3, which is a 6. When I take the 5 out of 25, what I'm left with is another 5. But I got to be careful with the 5, because I want to make sure that 5 times 5 is negative 25. So I'm going to make him negative. 5 times 6x is 30x. 5 times negative 5 is negative 25. All right. Do a few more examples here. I like number 5 because I know right away that 13 is a prime number. 14 has a 7 and a 2. So if 13 is prime and 14 has a 7 and a 2, they don't share anything in common. So in this case, there is no greatest common factor except for 1, and we're not going to factor out a 1. So in this case, cannot be factored. Those are the easy ones when they don't even have a common factor, besides 1, of course. 50 and 75. Now we got some bigger numbers. Let's just see how many more problems I have on this slide. Oh, yeah. Okay. 50 and 75. So let's take a look at 50 and 75. 25 times 2. 5 times 5. And 25 times 3. 5 times 5. All right. So let's just take a look. I have, for 50, which is my linear term, the part with the variable on it, I have 2 times 5 times 5. And with 75, I have 3 times 5 times 5. Okay, so as you can see, I now have 2 numbers that they share in common, and they're primes. So I'm going to multiply those numbers together to get my greatest common factor. So 5 times 5 is 25. That's going to be my greatest common factor. Now I need a linear term and a constant inside the parentheses. Now if I take the 2 5s out of this guy, what I'm left with is the 2. So I'm going to put a 2 there. And if I take the 2 5s out of 75, I'm left with a 3. And I got to be careful. I'm going to write 3 there, but I need to make sure 25 times this number has to be negative. So I'm going to make sure it's a negative 3. And when I check, 25 times 2x is 50x. 25 times negative 3 is negative 75. So the factored form would be 25 times the quantity 2x minus 3. All right. I would like you to finish 7 and 8. I'll give you a hint. One of them cannot be factored. Okay, but I want to see all this work on your paper as well. Okay, the actual factored form is going to look like this. All right, I want you to do those last two, and I want to look at one more on the last part. It says a square picture frame. Now that's important. This is a square. Has a perimeter of 20x plus 32 inches. What is the length of each side of the picture frame? Well, if I add this side plus this side plus this side plus this side on a square, it's adding the same side 4 times. So really what I'm doing is I'm taking 20x plus 32 and I'm dividing the whole thing by 4. So in order to reduce this fraction, it's not obvious. We need to, and this is where things are very important, we're going to factor the top. So I'm going to look at 20x plus 32 and I'm going to factor it. 5 times 4, 2 times 2, and 32 is 8 times 4, 2 times 2, 4 times 2, 2 times 2, all these 2's everywhere. So for 20, I have 2 times 2 times 5, and for 32, I have 1, 2, 3, 4, 5. 5 2s. So if I look for what they have in common, I'll let you finish this one up. Thanks, guys.